This is Miss Wiles, and she's wondering why the class is still talking. But now that you're not, we're looking at which expression is equivalent to 3x minus 2, that quantity squared. 3x minus 2 squared means 3x minus 2 times 3x minus 2. That's what that means. So when we are multiplying binomials, we can do the double distributive property, and we'll take the first 3x minus 2, and we're going to multiply both of those times the second. We're going to multiply all of this 3x minus 2 times that 3x minus 2. So 3x times 3x minus 2 and negative 2 times 3x minus 2. We use the distributive property. 3x times 3x is 9x squared. 3x times negative 2 is negative 6x. Then we have negative 2 times 3x minus 2. Negative 2 times 3x is negative 6x, and we put it under its like term. And then negative 2 times negative 2 is plus 4, because negative times negative is positive. We're now going to drop the 9x squared because there's nothing like it. We'll drop the plus 4 because there's nothing like it. Those things are going to happen whenever you have polynomial multiplication. Your first term and your last term aren't going to have like terms. Everything in between will have like terms. We have minus 6x and minus 6x for a total of minus 12x. And with confidence, we can say that this is our answer, and our answer choice is D. If we're looking at multiple choice, we should the only time that we'll have something like A, is when we have 3x plus 2 times 3x minus 2. Because when we have something like that where the signs are different but everything else is the same, then the center linear term will cancel itself out. B, the only time we're going to have this is when we have something that's imaginary, because it's not going to happen until you get into imaginary numbers. And the same thing for C. If those are imaginary solutions, and so they're not going to come into play whenever we have this kind of multiplication. So there are things that you should be able to look at and say, it's not even in my thought process as to what might be the answer here. And that's all I have to say about that.